All right. I suggest we get started. Otherwise, it all goes away from the time that you have. So, good afternoon to everybody that is listening. Welcome from sunny Eindhoven, my location at this moment. I hope it's just as sunny at the places you are at this moment. So, I noticed participants from many different parts of Europe. Welcome to all of you. And in addition to that, we're also live from the maintenance fair in Gorkum. A special welcome to everybody that is listening from there as well. Maybe to start with myself, I'm Jan Teun. I will be your moderator, facilitator for this afternoon, a regional board member for the NVDO and a member for the EHSEC committee of the EFNMS. In my daily work, I'm a maintenance and operational excellence professional. I've been doing that for quite some time now, almost 20 years. But what is the NVDO and what is the EFNMS? Most of you probably already know, but just to be sure, the NVDO is the Dutch Society for Effective Maintenance. It exists for several decades now and it aims to support the Dutch industry, with research and sharing of knowledge in its community, but also in being an advocate of our sector to other organizations. All this to make the Dutch maintenance sector one of the strongest in the world. What is the EFNMS? Well, the NVDO is a member of the EFNMS. The EFNMS is the European Federation of National Maintenance Societies. It unites maintenance societies on a European level. Its mission is to develop the maintenance professional, but also enhance innovation in maintenance and increase awareness of the importance and significance of our beautiful field. Now that we know that, what do we have in store for you? This upcoming hour, we have two presentations about confined spaces, an important and much discussed subject in occupational safety. The first presentation is from Mr. George Skroubelos. George is a long-time professional in the field of occupational safety, specifically in our field of interest, maintenance, of course. He will tell you about confined spaces, what the hazards and risks are, and how to handle them. The second presentation is brought to you by Mr. Adriano Paolo Bacchetta, just like George, working in our industry for many years. His presentation will cover confined spaces as well, but then from a more practical viewpoint. Okay, right. George, would you mind sharing your presentation and then specifically the first slide?
Okay. Good afternoon to all of you. Thank you for participating and investing time. Can you see my slides, Jan?
I can see your slide, but maybe would you like to do the household announcements or shall I?
You mean the presentation? I will be rolling the slides. So thank you very much. I'll be rolling the slides. It will be better this way. Is it okay?
Yeah, it's about the household announcements on the first slide. So in case of any reactions or questions, please use.
Yes, you can introduce the household if you like. Yes.
Right.
Thank you.
Thank you. So for reactions and questions, to make it a bit more practical, please use the chat function. I will answer the questions or, in case necessary, redirect them to one of our speakers. Also important to know, this webinar is going to be recorded and described afterwards, just so you know. And then finally, of course, the NVDO, the EFNMS and myself wishes you a captivating, instructive and all above safe afternoon. Then without further ado, George, the screen is yours.
Yes, thank you very much. So, confined space entry. Okay, this is only an introductory course. I hope it is going to be interesting for all you professionals. And I hope that the material, because in EFNMS, we always try to give to our attendees very practical material. We really hope that you use it and would definitely like your feedback. So, confined space entry. Okay, this is an initial training course and you can use these slides freely. The scope of this training is to help protect the health and safety of the personnel working in high-risk confined spaces So you realize that this personnel is mainly maintenance. So what is a confined space? A confined space is a space that has enough room for a person to work in. So this includes, again, maintenance professionals. It has a very limited access and exit, which is usually only one, usually, not always. In some silos we have two manholes for entering and exiting, but that does not reduce the hazard of the confined space. And of course, it is not designed for continuous occupancy. Again, here, that means that maintenance professionals, which usually go to spaces not used usually during the normal course of operations, but they do enter confined spaces. So we consider this a very important seminar, very important approach. Now we have generally two types of confined spaces. The ones that require a permit, that means in order to access the interior of a confined space, depending on the hazard, must be permitted first. Why? What are the hazards entailed? First of all, a hazardous atmosphere. That means that the environment inside a silo, a pit, we're going to see some examples, may be hazardous for health, or it can contain a material that can trap a worker, and in this case, again, a maintenance professional, or it could trap a worker because of its structure. Okay, like for example, in mixing vessels, we not only have the space which is inside and not only the material, but also have electromechanical installations. Okay, and although it could present other hazards to the employees, there is a small typing error which I'm going to correct on health and safety, which we're going to discuss. Of course, there are other areas with the same characteristics that are not that hazardous, so the risk is low, even if we work there in not normal conditions, under non-normal conditions. So in this case, access permit for these areas are not required. So, but only after a risk assessment is conducted, and under this risk assessment, we conclude that the area does not pose any threat for the health of the workers. So, for example, permit required confined spaces could be tanks, manholes, pits, ditches. Yes, even open ditches could be characterized as confined spaces. Also, large sections and length piping, especially sewage, for example, main electrical panels, and ventilation ductwork. Of course, this is not a complete list. This is an indicative list. For example, you see here, these are actual photographs for my archive. This is a water-based tank storage manhole, and one can enter into the water tank, okay? And in this case, in spite of the fact we have water inside, this is considered, in fact, a confined space. So a confined space may be hazardous in spite of the fact it does not contain a hazardous material. It could contain water, but it still characterizes the permit required confined space. This is a tank of water-based raw materials. Okay, so in this case, we don't have only one entrance, we have two entrances, but that doesn't make any difference. It is still a permit required confined space. Why? Because there was a risk assessment conducted, and it was concluded that in order to enter and conduct operations in this kind of confined space, we need a permit. Let's see the hazards. The hazards is, of course, one of the worst is the asphyxiating atmosphere. Okay, because if we are trapped in an asphyxiating atmosphere, you understand that death is imminent. We may have a toxic atmosphere. We may have a flammable explosive atmosphere. So under certain conditions, we may have an explosion or a very intense fire. We have also mechanical hazards, as we discussed, entrapment hazards because of the material, and other hazards which we're going to mention. Now, why do people suffer accidents? And most of them are unfortunately lethal in confined spaces, because they think that they can conduct temporary works without permit. So we have an authorized entry. They rely sometimes on their own senses. For example, this is a water tank. Why not enter? It's just water. If there's something hazardous in there, I'm going to smell it. And they become very familiar. Unfortunately, this is a general a general characteristic of maintenance personnel, because they are well trained usually, and they are professionals, and they have very let's say large experience. They think that they can overcome any hazardous situation, which, as you know, is not the case. Also, people think that they don't need supervision just because they have the expertise. That's not true, because in a confined space, we have special hazards. And also, this is what Paolo is going to cover, because they attempt rescue within the confined space. They go in, that is, which is really, they take risks, unnecessary risks, and that usually end up not in the best way possible. So actually, we have to have a safety work program in which we identify, we have a registry of all confined spaces and their types, even the ones that we think do not require a permit. So make a list of all confined spaces, whether you believe they require a permit or not. Okay, then we have to conduct a risk assessment, which means make a hazard analysis, and we have to take measures. We're going to see some pictures, like putting up the correct signs, conduct measurements, assign responsibilities, and of course train everybody in order to be able not only to fill in the work permits, but also to check them. Last but not least, because we are people and we make mistakes, and sometimes we cannot foresee everything, we need to have in place a rescue procedure. Now, let's a little bit, okay, in the time frame we have, elaborate on the hazards. Of course, you understand, as we said, this is the worst one, as an asphyxiating atmosphere, which means lack of oxygen. Okay, so you know that in the breathable air we have a little bit less than 21% of oxygen. The permissible limits are between 19.5 to 23.5. I remind you that if we have an oxygen-rich atmosphere, this atmosphere is flammable, and in some cases, if not most of the cases, maintenance personnel conduct hot works in these areas, or they may be called to conduct hot works in this area, so we're going to have an explosion. And while if we are between 16 and 19%, this is considered a danger zone regarding the percentage of oxygen. I just want to note here that NFPA is now conducting research, and this danger zone may be limited. That means that it may be required that even above 19%, this danger zone maybe become broader, between 16 and 19.5%. So no area, no work may be conducted if the oxygen is less than 19.5%. Okay, this may sound a very small percentage, but actually it is not. And then we have, if we have less than 16% of oxygen, the things become very difficult. Work cannot be performed, so the area has to be evacuated. The confined space has to be immediately evacuated. Okay, of course, below 14% and close to 6 to 10%, we have loss of consciousness, and below 6%, we have death within 2 to 3 minutes. Now, how can we have this situation? How can lack of oxygen be achieved? Don't forget, we are internal combustion electrochemical engines. That's what the human body is all about. So we ourselves consume oxygen, okay, because people tend to forget this. So air has to be renewed. We're going to come to this later. Also, As I said, in most of the times, hot works, repair, maintenance works are performed within a confined space. So combustion, again, here consumes oxygen. We may have oxidation, especially when we enter in vessels where there is intense corrosion. Okay, so that's why measurements beforehand are very, very important. We may have decomposition of biological agents, like, for example, in sewage pits. And of course, we may have a leakage of an asphyxiating gas, like it could be nitrogen, it could be CO2, carbon dioxide. As you know, most of you, nitrogen is used in edible oil tanks, okay, and also generally in the food industry. So this is also very important. It's a hazard agent that it's a risk factor that we have to take into account. Okay, so let's move on. We see here in a more detailed form the three types of hazards and how the mechanism that can consume oxygen within a confined space. Unfortunately, we take for granted the fact that we think that if we are in a confined space, that's the same as working outdoors. Well, it's not the same. Okay. Also, we may have a toxic atmosphere. Okay, so we have to actually risk assess what is the material we store in the confined space, or if some other material or chemical substance can be created in the confined space due to this storage. We may have, for example, fumes created. Okay, and of course, don't forget that in some cases, we ourselves introduce chemicals inside the confined spaces because, for example, we clean the interior of the confined space. So all these have to be reassessed. That means that we have to conduct a risk assessment per task, actually a task hazard analysis. As I already mentioned, we have also, there's a possibility that we have flammable substances in the confined spaces. So that's something we have to measure. And of course, we should know the properties of the potential gas inside the confined space, which means that we have to make very analytical measurements as well and compare them to the SDS data. Equipment also and the space configuration, because we said, don't forget that we have also long horizontal confined spaces, like, for example, sewage networks that may contain, for example, pumps, right? There are all types of installations. We cannot go into the detail. That's why in there as well, we need a very comprehensive risk assessment. And actually, especially in pits, and for example, we may have a biological purification system of differential aeration. That we have a lot of mechanical installations there, as well as electrical installations, as well as sharp surfaces, slippery surfaces, abrupt surfaces. Okay, so for example, biological purification system of differential aeration, because they have large fans, it's a very good example where a confined space risk assessment, very analytical, has to be conducted. In some cases, we have engulfment and entrapment. So because of the material, the bulk stored material, or we can be entrapped in the geometry of the confined space. So this also has to be very, very carefully risk assessed. You understand, it's the hazard level is the same as the asphyxiating atmosphere. For example, in grain silos, we have this hazard because people cannot float in grain. So sometimes my experience shows that in grain silos, in agricultural installations, people go in to maintain or check or inspect, and they do not wear they don't wear safety harnesses. Okay, which is compulsory, even if you want to enter a silo, a grain silo, just for inspection. or for quality reasons. And of course, we have the microclimatic conditions, because the body is very sensitive to heat, cold, and also to noise, humidity. And if we're going to conduct some maintenance work that is quite demanding, we need the correct levels of lighting. In some cases, we may have to examine other factors like slipperiness and radiation. And we also covered other hazards like chemical and biological hazards. Especially in agricultural facilities, we may find in confined spaces reptiles, rodents, and insects, which, by the way, are also very, very hazardous. Okay, now we divided and we categorized risks, but in a number of cases we have combined risks, which also have to be taken into account. Okay, I cannot elaborate on this, but please take into account that we usually in a confined space we have a combination of the risks that have already been mentioned. Now you see the demarcation. Okay, there only recently the lower sign has been approved as a general fine for confined space. But if you are not using this international label, it doesn't matter. You can use any other label unless you make the message clear. Of course, there are specifications, you know that. Sign has to be clear to read, robust. It has to be very well maintained, or substituted in case, replaced in case of wear and tear, and it has to be near the confined space entrance or entrances. So you see here some examples. On the left hand side, you see a sprinkler water tank of 1,000 cubic meters, and on the right hand side, you see a production area raw material tank. Now, this is also very important before entering confined space, in order to make sure that there is no asphyxiating environment or environment dangerous to our health. We have to make the following measurements, and they have to be conducted in that order. Okay, now one point of attention is that we must understand that if we have a vertical confined space, that we may have the hazardous agents, especially gases. Okay, we may have layering, which means gases will be layered throughout the height of the confined space. So it's absolutely important for us to see and assess if we have layers, and of course have the proper instrument, which means that the probe has to be long enough in order to be able to reach straight to the bottom. So one measurement may not be enough if you have a vertical confined space, which is, for example, more than 3 meters, but that's just an example. Okay, don't take my word for it. It's not only 3 meters. Okay, you have to risk assess. So we have to know the gases that may be present per level and conduct the measurements throughout the height of the confined space. Of course, if the measurements are off limits, we have to ventilate the area and conduct new measurements. So these are some examples of potential gases that may be found in confined spaces. I'm sorry about that. Now, ventilation assures that asphyxiating atmospheres are less likely to happen. So ventilation has to have special characteristics, has to be continuous. It must not create additional risks. So when we have a confined space, that means that we may need to identify whether we are going to have by aeration. We may have to create an explosive mixture. So in this case, we have to make additional provisions, as we're going to discuss. Now, the usual method is a centrifugal supply fan with flexible inlet hose. We're going to see one picture, but please, if you use this kind of hardware, please use a certified material and only special fans that are used for confined spaces, because the fan must not be close to the entrance. That's why we need the flexible inlet hose. Okay, so, and in some cases we may need both air supply and air extraction. Okay, so this is also very important. So you see here flexible air supply hoses that are dedicated to this purpose. Okay, so please don't use hardware that is not tailor-made for this purpose. And you see here some examples of the issues that we have to take care. So ventilation is not self-explanatory. You have to make some kind of a risk assessment regarding or a study, or you have to be very careful how do you design the ventilation of the confined space, because the fresh air has to reach especially the worker, and has to be it has to ventilate the whole volume of the confined space. So this is very poor ventilation. And also we have some specifications, like for example, we never supply oxygen at the perimeter confined space. You understand that, because it creates a huge risk of explosion. And if we have flammable concentrations above the upper flammability limit, so we do not supply air. Why? Because what we do is that we lower the concentration of the flammable gas, and it drops below the upper flammability limit, so it comes within the flammability range, and we may have a fire or an explosion. And also for environmental reasons, if we have toxic gases, so we also have to conduct a specific design for perimeter required confined spaces, because toxic gases must not leave the the confined space. So it has to be controlled for environmental reasons as well. Again, we have that the airstream must not cause disruption or other unsafe conditions like dust, for example. We should not bend the vent, because then we have insufficient ventilation, and we have to pay attention of how the air affects the ambient, the general conditions of the working space. So you see here some examples of correct ventilation in cases where we have two entrances, and in case we have one entrance to the confined space. Of course, there are standard and additional personal protective equipment that we should use and we should specify, and this should be listed in the permit. And whether you're going to use additional or not personal protective equipment, you understand this is part of your risk assessment. Now, for the permit, because we're talking about a permit, for all permit required confined spaces, we have to issue a work permit. Okay, and in just few words, because we don't have the time, the permit as a minimum has to have these fields. Okay. So these forms have to have these fields, but this is again an indicative list. Okay, now we have to have a multi-fold, so several copies have to be issued. Now we are in the electronic age, so we have to print several copies. Okay, and depending on the team we're going to put together, we have to have multiple copies. Because we may have to conduct a last-minute risk assessment, or we may have to conduct a rescue operation. So we have to have multiple copies. Now, near the entrance, near to the sign, we have to put up also to post the permit form. And we're coming close to the end of my presentation. Of course, we have to have other control systems. Like, for example, we may have to rinse the confined space if there's a lot of dust in there prior to entering, or there are, in most cases, we need lockout-tagout procedure and line braking if we have equipment, if we have supplying lines. Again, artificial lighting is usually necessary in order to provide the necessary illumination for the maintenance people to work. Communication hardware is also very important because in several cases, if not in most of the cases, the supervisor does not have visual contact with the person working inside the confined space. If there is a fire hazard, fire extinguishers have to be supplied, appropriate of course, and you see in the image a tripod kits that are usually that should be used for a quick rescue. Of course, we saw the forced ventilation equipment and of course the demarcation. These are some tips of how to prepare the system. So we have to remove combustible materials at a specific radius, protect the access routes, additionally to being supervised, and conduct also measurements in the surrounding area, because don't forget that we supply area from the surrounding environment. So this air has to be, to a certain extent, clean. And these are 2 pages of general safety rules, which you are welcome to elaborate on, which means that we should, following the health and safety strategy, try to avoid working, if possible, in a confined space. Industry 4 is going, digitalization is going to help us towards this direction. There are also technologies now that have limited the confined space work, which is very good because we eliminate the hazard at the source. This is also very important. Not everybody can work in a confined space. So a health clearance certificate has to be obtained from the occupational health doctor. Of course, workers have to be trained, even if they think they know everything. All involved parties, involving the supervisors, have to be trained in the safe working procedures. As we said, we have to create a registry of the confined spaces, even if they are not permanently required. Review the risk assessment continually, even with a last-minute risk assessment, and which is the next one. And of course, conduct the air quality measurements, as we said, starting with oxygen. This is very important for you to remember. In some cases, I must note, you may have to purchase explosion-proof equipment. In my opinion, you should all obtain explosion-proof equipment to conduct measurements inside the confined space. Okay, of course, we have to have the necessary signatures, decide on the ventilation method, because this is, as we said, very important. We have to have the appropriate ventilation and ventilate the area if you think it is required. We do not insert, should we need to use some kind of breathing aid, like for example pressurized air, the bottle will have to stay outside. We have to ensure and check regularly that the ventilation reaches all areas of the confined space, use the appropriate PPE according to the risk assessment, and of course ongoing monitoring, including communication, has to be ensured. And last but not least, once a confined space operation starts, the emergency teams have to be on alert. So that concludes very briefly my presentation. Thank you very much. I think we're going to have the questions later in the session. So Jan,
okay, thank you,
the
George.
floor is yours.
In case there are no other questions, I would like to give the floor or screen to Mr. Adriano. Please go ahead.
Okay. So you can see my slides?
Yes.
I share. Okay.
Yeah, we can see them. Thank you.
Okay, I can start. Thank you, George, for his presentation, and I'd like to thank also NVDO for the opportunity and the possibility to share experience with the expert maintenance manager about confined space works. 2 words about me. So I am the president of EHSEC, that is a research association that works on workplace, on-place, and leisure activities safety. And our target is to develop one community of practice for easy dissemination of the results obtained with our research and the increase in safety culture and in any context. I am also president of EHSEC. EHSEC is the European Association of Industrial Rescuers, that are the emergency specialists that works during rescue operation in industry maintenance works. So when we speak about at the international level about the standards for confined space, we make reference to OSHA, in particularly to OSHA for general industry and OSHA for construction. Why is so important to well understand the differences between these standards? Because construction is a specific area where there are different situations where employee cannot see or can underestimate the others of confined spaces. So we know that maintenance is an important and inevitable service function of an efficient production system, and everywhere maintenance operators are called to guarantee the smooth and efficient working of the industrial plant, and maintenance management helps in improving productivity and to guarantee the continuity on business production. But we have to consider that around the world we have more places where confined space are entering every day. Oil, gas, refinery, freight, transportation, and other. And for this, a lot of people every day entering confined space to perform their works, the work functions for construction, routine or not routine maintenance, repairs, modification, rehabilitation, and inspections. So looks this one. So as you have seen, the workers were painting the underground tank with a solvent-based paint, and without ventilation, the solvent concentration in the air went up the lower explosion limit, and the skin temperature of the no-ATEX lamp emitted the internal explosive atmosphere. For this, it's clear that our first goal is to avoid entering confined space if possible. In any case, we have to see if it's possible to modify the confined space itself to avoid entering, or if it's possible to work from outside. And there are some if entry to confined space is unavoidable, we have to take some precaution, and we have to take to make something for reduce at minimum the risk. And if it's not possible to avoid to entering, we have to take a lot of precautions to eliminate control hazard and reduce the risks. Please note that normally we have to work considering the actual situation of a confined space. So if the pressure vessel is done in this condition, we have to entering from the manhole, but it's possible that we, for the future, we can change this situation. For this, it's very important to design new confined space according to with safety principles. Regarding maintenance works in confined space, we have to consider that access inside is not frequent, and for this, many site managers believe that there are no particular reason for concern about it. How many times we can hear words like, it doesn't matter, the works take only a few minutes, or other similar words. According to OSHA, we have to remember that 11,000 injuries could be prevented if employers and workers had simply implemented a well-designed and properly executed monitoring and rescue plan and followed the procedure outlined under OSHA. Please remember that in confined space, accident rescuers are about the 50 and more of victims. Fatalities could happen unexpectedly in no time. And if workplace seems safe. If the body rests without oxygen with a few seconds, fatality can happen. Hazards often are not present at the beginning of the activities, and for this it's very important to monitor the workplace and the supervision activity in confined spaces. Please remember that can happen a situation like this one. This is an accident that you can see what happened. But how many times could it be done this way? We have to be, and also the guys that was working was really trained for identify confined space. So for this is very important to be sure that all people that works also in construction industry have to be trained on confined space. They have to understand what is a confined space, what's the problem, and how to identify a confined space also in a construction work. For this is important that OSHA stated 2 different standards. And we have a lot of people that enter in confined space, and is very important to understand that more than 50% was rescuers. And the other big deal that we have to take into account is that the NIOSH investigation evidenced that 85% of the time the supervisor was present, but we had an accident. 29 of the dead or the people lost life was supervisor. 31% had written confined space entry procedure, but nobody used the written procedure. 50% had confined space training, only 50% had confined space training. No one had a rescue plan. 60% would be rescuers and died. 90% were authorized by supervision, but nobody were tested before entering the confined space, and no space were ventilated. This is very, very terrific. OSHA used the term, and during his presentation, George has well explained the OSHA definition of permit required, the confined space, and the permit required confined space. Employees' responsibility are to guarantee a safe workplace by adopting all appropriate precautions to ensure work safety. Please note that in Europe doesn't exist a unique definition of confined spaces, and each country established its own classification and legislation on confined space. It's true, we know that at European level, the approach is risk-based and on a case-by-case basis. For this is important to identify the hazard and evaluate the risks for any workplace and take the appropriate measure for safety at work in confined space. We have another big problem that is true. Lookout tagout procedure is very important to do, but sometimes we have a problem. Sometimes it's not possible to stop all the industrial activities, and for this is very important that during maintenance works we have to apply a completely to consider this during risks evaluation. So we have to well understand what are the place where we have to do this work, and if it's possible to do, it's true. Normally we have to do lookout tagout everywhere, but sometimes it's not easy to do. For this, the risk evaluation and the appropriate measure for safety, for the security of people must be put in place. About another example is about pressure vessels. So we know that pressure vessel must be tested, and also we can entering pressure vessels for maintenance also. And normally the manhole is so little, so small. Normally is 30 for 40 centimeters, so about 20 for 16 inches. And for this, we have to take all the measure to guarantee the safety of operators. Also because the space that we have inside the pressure, this is a steam generator and exhaust fume pipe steam generators, and we have to considering also the space that we have inside the pressure vessel to evaluate the risks about the operations. So we, during our research, we tested problem to entering for confined spaces, in particular steam generators, for maintenance works and rescue operation. And you can see some pictures about this. And also we test the problems about the rescue operation from another steam generator. This one is a piece of water pipe steam generator, and we try to test how it's possible to rescue people from the internal of the pressure vessel. And as you can see, we try some different devices for the rescue. And also we had the opportunity to test the effort of rescuers during a rescue operation. We used an Wi-Fi monitoring devices, and we made some blood analysis for check some parameters about the effort and what the force that rescuers have to is involved during the rescue operations. And reference to our cooperation with CAN, we present our results during the 2019 EUROSNET conference in Dresda. We have to remember that the extreme variety of operational situations related to confined spaces requires much research and sharing of experience. It's also important to compare different methodological approaches and effective measures to find how better to guarantee a safe workplace. Operational guidance are required to allow uniform application rules, starting from a precise and unambiguous definition of confined space and their warning signs and the criteria for the training required, as well as for rescue management operation, to qualify companies and employees working in this context. When we start to think about the rescue operation, in general, and particularly for confined space, when an accident happens, it is important that the response procedure is well working. And we need a clear incident management system in place. Also, we have to answer ourselves. How to alert the internal rescue team? How is possible to call for the internal rescue team? How much time takes the internal rescue team to arrive to the place to start the rescue operation? How much time for professional rescuers, firefighters, paramedics to arrive to the place? What internal rescue team can do waiting for the professional rescuers? So they are well trained and they have all rescue equipments and PPI to do the rescue without risking their safety. And this is important because when we are looking for to work inside a confined space, we must be sure that our emergency plan works and works good, well. And the other problem is that we have to stop the increase of persons that lost life because they try to make a rescue assistance for the colleague, for the co-workers. Rescuers must be safe, and a rescuer safe can rescue the co-worker. No way for do in other possibility. So, when professionals are arrived in place, the incident command system must be changed in incident management system. So it's quite different because in one way you must be able to manage. In the other way, you must be sure that the command chain is okay. So must be clear who command, who is the chief that say to the other what we have to do now. It's true, the professional rescuers must be understand exactly what the kind of problem and what the characteristic of the structure, and for this make a lot of questions to people that works normally in the area to take informations, but after one people must be able to take the decision, and all the rescuers that are on place must do what the chief says. You have to do this, you have to do this, and you have to do this. This is really important to avoid to lose time during the rescue operations. And obviously, in this situation, we have to understand how is better, how is possible to have the best situation to for preparations, assessment, pre-entry operation, entry rescue operation, and termination. So all these phases must be done quickly, but with the correct sequence. Remember, as is important, the safety of rescuers. Okay, and the approach assessment must ask everyone have to think about the question that I show you in this slide. So at the end of my presentation, confined space activity are obviously high risk operation. For this, is very important to identify all the hazards, do a good risk evaluation, identify the right work procedures, and the necessary instrumentation, gas monitor and other, and the other work, the other tripod or other kit for rescue, and the PPI. And also is necessary put in place a well-designed plan for the activities. Emergency plan must be tested to be sure that works properly. Finally, remember that never rescuers have to be at risk during rescue operation. Thank you very much for your attention. Jan, okay.
Yep, I unmuted myself.
Okay.
So thank you very much, both speakers. I believe some very valuable content. I can imagine a lot of useful information for the people that have been listening, both in Gorinchem and online, of course. So far, I have seen only one question, and that is about the slides, if they can be shared. Let me put the final slide on screen. And that's a yes, the presentation will be shared, of course. It has been recorded, as I mentioned earlier. And it will be uploaded to the NVDO YouTube channel, and everybody will, of course, receive a link. I see a question coming in from Antoine. Are places where it's difficult to be safe from mechanical hazards considered as confined spaces, even if there is no risk due to the atmosphere? Can we give a good definition of these spaces? I can imagine this being a question for George.
Yes.
Yeah.
Yes, they are considered permit required confined spaces. Don't forget that when you conduct a risk assessment, we need to know whether I'm going to call them all maintenance workers, because these are the ones that usually access a confined space. Yes, mechanical hazards, all these hazards that I mentioned have to be considered independently. So if you just have mechanical hazards in a mixer, for example, which may be an atmospheric mixer, okay, yes, it is a permanent required confined space, and it's very important to have a very stringent, very strict lockout-tagout procedures in order for the mixer not to start, of course. All these hazards are independent, and that is why I want to mention what Adriano said, which is very important. Unfortunately, in Europe, there is no uniform approach, not even to the definition of a confined space. So maybe we should consider in the European Union developing a confined space standard in which we're going to also define what a confined space is and if it should be a permit required or not. But definitely, yes, these spaces, even if you only have mechanical hazards, yes, they have to be permit required.
Thank you, George. Mr. Adriano, would you like something to add, maybe?
No, I think that the question is correct. So the problem is true at European level is very difficult to find an definition of confined space, and also there are not procedure, because in Spain we have something, in German is different. For this, I hope that will be possible to have one at European level, one definitions, and it may be a standard, because also normally we referring to OSHA, NIOSH or other, but why not one European standard about confined spaces?
Yeah, that sounds like a good solution, I can imagine.
Yeah, but it's quite difficult.
But it will probably take some time.
Yeah.
Yeah. Perfect. Thank you very much.
Jan, I would like to add 2 comments to my presentation, if I may.
Yeah. Okay.
Okay. Now, one, some of you may have wondered, should we use monitoring badges? You know, these little badges we wear for oxygen deficiency or flammable gases. The answer is yes, but we should not rely on, I'm sorry about this, we should not rely to monitoring badges. Okay, because unfortunately they give us a false sense of safety, because we have a self-monitoring badge, we can go in there without supervision. Okay, and also we must not only risk assess the confined space as such, we should also risk assess the type of the problem we are facing as maintenance professionals, because you may enter a confined space to conduct cleaning, or you may enter the same confined space to conduct welding, or you may enter a confined space because there is a leak. So even in this case, even a line breaking procedure is not enough. So please, of course, in 1 hour seminar or presentation, we cannot cover everything, but because there was some time, I thought I should add these comments to this presentation. Thank you very much.
Okay, only one thing also from me. Please remember that monitoring doesn't avoid the ventilation, because the problem that inside the space is possible that the situation can suddenly change, and it's possible that the only tester start with the alarm, but you haven't time to escape. For this, every time when you walk in confined space, everybody must be sure that there are a correct ventilation inside to guarantee the right oxygen level. And that's all.
Thank you very much. We are a little bit past our time.
Okay.
We were scheduled to conclude on at 2 p.m. It's a little bit past that time. Apologies for that. Besides that, I would like to thank everybody for participating in this webinar. In case of any questions, feel free to contact one of our speakers or both, of course. And finally, enjoy your afternoon.